Good day, folks. Welcome to my YouTube channel. If you're new here, please don't forget to subscribe and like my videos. Watch my videos till the end and don't skip the ad. Let's do this question. This is September 2024. It's a Limpopo province and it's an electric circuit. Let's cut the chase. In the circuit shown in the diagram below, a reading on an ammeter A1 is a double that on ammeter A2. So meaning in this circuit, the current comes in this direction. It's a total current. So the current here in A1, it's a double current in A2. Let's see A2. It's a total current, and that ammeter reads the total current, and then there's a split of the current, and there's another current that goes this way, and then that split, it goes there. So the split that passes in A2, which is this whole current that splits here, the A2 is a double of this one, right? No, A2 is a double of this one. In other words, A2 is a half of this one, right? That's what A1 is, a double of this one, right? And there's another current that goes this way. But looking at this circuit here, let's use the colors. It's a total current there. It's a total current. It's a total current there. And then there's a split there. There's a split. It's a A2 current there. And then there's another current that goes this way, right? So, and then it combines again and it becomes the total current. It passes in the 9th ohm resistor. It's a total current again. Remember, there's an internal resistance there. Right, let's continue. It says, and a reading on V2. Where's V2? It's a voltmeter. It's a potential difference in that resistor 2. And the reading on V2 is 3 times the V1. Okay, so let me write these things here. The ammeter, the current in ammeter 1 is equal to 2 times the ammeter in A2. That's what it means, this thing, right? And then now it says the reading in voltmeter 2 is 3 times V1. So V2, so the reading here is equal to 3 times then V1. So here it's 3V and this one is V, right? So V is equal to, V2 is equal to 3V1, right? Which is, in other words, is going to be equal to 3V because V1 is V, right? If you can see here, guys, we have 2 resistors here. We have a parallel line and the parallel line there, and this one series. So this whole circuit, it's a combination of a series and the parallel. But you need to be careful in this parallel. The 2 resistors that are in series, when you combine them, they are parallel to this one, right? So it's not only this that is parallel to this one and that parallel to this one individually. The combination of them is parallel to this one, right? And we're given the EMF there. The EMF there, it's 20,4 and the internal resistance is unknown, right? They say in the statement the EMF of the battery is an EMF of 20,4 and an unknown resistance R, right? It says define the term EMF. The term EMF, guys, is very important to define it according to the exam guideline. The EMF of the battery is the maximum energy provided by the battery per unit charge passing through it. Right? Stick to exam guideline. I'm not going to write it. 8.2.1, it says calculate the resistance of resistor 1, resistor R1. We want the resistance of that. Which one of these things that we are given here that is going to help us here? So very important. What is going to help us here is the current and the voltage. So guys, in order to know what was the, when they want the resistor 1 R1 here, the only thing that we know here in this line, it's this resistance, right? And we do not know the resistance of here, and we do not know the voltage here. We know just that the voltage of this one is V, and this one is 3 times of this one, right? So what we can do, we know in parallel the voltage here, the total voltage here is equal to the voltage here, right? So what we can do here, we can try to get the voltage of V2, all right? Getting the voltage of V2 is equal to this plus this, right? So what we can do here, guys, we can say, in order to get that, let's start here. Let's say 8.2.1. We can say, we can start getting the voltage here first, right? The voltage here of the V10 ohm is equal to the 3V, which is the 3V is this one. Remember, the voltage of this parallel is 3V, and the voltage here is 3V. But particularly, we want the voltage of this one. I'm going to show you where we're going to do that. So we're going to say this minus this, it will give us that. Why are we using this one? This will help us to get the current that passes here. If we know the current that passes here is the same current that passes here, it will enable us to get the voltage there, right? Yeah, let's do that. So it's 3V, which is this one, minus V, which is the voltage of here is 3V, and this one is 3V. But we are told this one is just V. So if this one is 3V and we have a V, that means this one is 2V. And then here we get the 2V here, right? So that means the voltage here is what? Is 2V, right? So having 2V, now the voltage is 2V there. What is going to help us to get the R1 now, right? What is going to help us? Now we're going to, what we're going to say now, we're going to say, okay, let me just erase here. So this is 2V and this is V. So we're going to say the current that passes here is the same current that passes there. So what we're going to say, we're going to say the current in R1, which is this one that we're interested in, is equal to the current that passes in 10 ohm resistor, because they're in the same line there. So we know the formula that says I is equal to V over R. So here we're going to have V. What is the V in R1? Is V. And then the resistance here is what? Is R1. And then in the 10 ohm resistor, what is the V? There is 2V. And then divide by the resistance. What is the resistance there? It's going to be what? 10. And then we cross multiply. Cross multiplying there, we're going to have V. Okay, let's do it like this. We're going to say have R1 times 2V is equal to V times 10. It will be 10V. And then we divide by 2V. And then the R1 is going to be this cancel and this V and V cancel. You're going to have 5. It's going to be 5 what? 5 ohms. So that means the resistance there is what? Is 5 ohms. I hope that makes sense, right? Let's go to this question. Calculate the resistance of R2. Now, getting the resistance of R2 here, we have to be smart. Guys, I can confirm it to you. This is not easy. This is not an easy question, but they are easy. They really need you to think out of the box, right? Now what we're going to do now, we are looking for R2. Looking for R2, what do we know? What is going to help us to get the R2? The R2 is this one, and we have the R1 there. So what is the commonality between the two? What do we know? Let me 8.2.2. What is the commonality between the two? What we know is that the voltage in V2, which is in R2 here, is equal to, the V2 is 3 times the voltage of V1. This is what we said here, right? So having that information, from the formula that says V is equal to IR, we have a V here, but if this V is referring to this resistor, so it's going to be IR. Which resistor? It's going to be what? R2. And on this side, it's 3 IR, but it's going to refer to R1 because it has to do with the V1. So it's going to be IR1, right? Do we have the current there? We do not have. What are we looking for? We're looking for R2. We're going to make R2 as a subset of a formula. So we divide by R, we divide by I, we divide by I. So we're going to have R2 is equal to 3I R1 divide by what? Divide by I. So that I and I will cancel. So you have R2 is equal to 3R1. And then what is our R1? We already have the R1 is 5. So it's going to be 3 times 5, which is 15 ohms. So the resistance of R2 is what? Is 15 ohms. I hope that makes sense, guys, right? Okay, let's go to the next question. It says the reading on V2 is 9V. Now we are told here on V2, the reading here is 9V. So what do you need to be careful of? Let me use another color. What do you need to be careful of? This resistance, it won't change. This resistance is the resistance here, which is 15. There's 15, it remains the same. And this resistance 10, it won't change. Even the EMF, it won't change. It's still the same, right? Now telling us the V2 is 9 volts now. This V2 is 9 volts. Guys, this was not 3 volts. It was 3 times the voltage of V1, right? Okay, now it says calculate the potential difference across the 10 ohm resistor. Calculating, it's 8.3.1. We want the potential difference here. The potential difference here, right? We wanted this V. We know it's 2 times V, which is 2 times of this one. But we want to know this voltage, right? This is 1, it's 1V, and it's 2V, and it's 3V, right? So what are we going to do here? What are we going to do here, guys? We are going to need to be smart about it as well here. 8.3.1. So what is going to help us here as well, to get the potential difference there, is that V2 is equal to 3 times of V1, right? Which is, we're still talking about these two, right? So we know V2, we're given the V2. This is dirty now. This is dirty. We're given the V2, it's 9 volts. So why can't we substitute V2, it's 9, and then 3V, and then it's going to give us V1, and then we divide by 3, it's going to give us V1 is equal to 3 volts. So the voltage here in V1, it's 3 volts. here it's 9 volts, and then this one it's 2V. So the 2V, here if V1 is equal to 3V, and then this one is 2V, that means it's 2 times of V. I'm not sure if you get me there. So we're going to say the V in 10 ohm resistor is equal to what? 2V. And then what is our V? It's 2 times 3. V is 3. This is V. This voltage is V. And this is 3V. It's 3 times V, which is it's 6 volts. Right? I hope I make sense. Okay, alternatively, what we can say after this, we can go to and calculate the current. We can calculate the current here. The current that passes here. Because here we have the resistance, we have the voltage, it's 3V, right? So we can say from this one, we can say I is equal to V over R. There, what do we have there? This is resistance in R1. And then the current there, the voltage there is 3. We divide by the resistance there is what? It's 5. 3, 5. I don't know what's there. 3 over 5, guys. I'm going to leave it that in a fraction form. And then after getting that resistance, we're going to get the formula that says I is equal to V over R. Now, where am I going? Now, having this 3 over 5 current, it's a current that passes here. That means the current here, it's 3 over 5 as well. So I'll say 3 over 5 is equal to, now the voltage there, I do not know what is the voltage in the 10 ohm resistor. That's what I'm looking for. So I'll say V, and the resistance is 10 there. And then when I cross multiply there, your V, it's going to be 6 volts, which is the same answer as this one. Same answer, right? Now let's go to the second last question. It says calculate the reading on A1, which is the reading on A1 is this one, right? The reading on A1 there, guys, first, knowing the, okay, let me erase. Knowing the current here, and knowing the current there, and knowing the resistance, because the resistor here, it's 5 and 10, that makes 15. And then the current here, it's 3,5 here. That means that we have a lot there. And the voltage here is what? It's 6V and 3V. That makes 9 volts. That means here it's 9 volts as well. So in order for us to get the reading, so we take the current of this and we add the current of this, right? So what I'm going to do, did I calculate R2? Yes. I have R2 here, which is the resistance, it's 15 ohms, and the voltage, it's 9 ohms. So I have the current here, it's 3 over 5, and I can calculate the current here and add the 2 and give me that. So I will say it's 8.3.2. I'll calculate the current in R1. In R2, which is the current here. So I'll say current in R2 is equal to V over I. V over I. The voltage there is 9. And the current, R. I is equal to V over R, which is the R2. The voltage there, it's 9, and the resistance there in R2, what was it? it was 15. It's 15. So this is going to be 3/5, which is the same as the top. That means the current here and here are the same. So which is the total current there? It's going to be the total current. It's going to be 3/5 plus 3/5 is equal to 1.2 amperes. Alright, that means this is 0.6 and this is 0.6. Right, the last question. Calculate the internal resistance 8.3.3. 8.3.3. Right. From this formula that says EMF is equal to R external plus R internal. What do we have here? We have that, we don't have that, we're looking for that. So we'll need to first get the R external. The R external, guys, you need to be careful here. You need to be very, very careful, the R external, how we get the R external. Right, let me erase here. The R external, guys, it's made up of this series and make it parallel with this one plus this series. It's a series in parallel, this one, right? And so you make the parallel of these two plus this one, that's R external. So the R external, it's going to be it's going to be made up of 9, which is this 9 plus the parallel. Okay, let me put it this way. Let me say R external is equal to R series plus R parallel. So the R series is 9 and the R parallel is the one that is on top, which is 10 plus 5, which is the resistance here, it's 5. 10 plus 5 times by 15, which is this one. I added these two. This is super dirty. Guys, this question is not easy, but it's doable. Remember, guys, this was 15 ohms and this was 5 ohms, right? So it's going to be 10 plus 5 plus 15. So if you punch that in the calculator, it will be 16.5 ohms. That's R external. So we go back to the formula. I is equal to R external plus R internal. And then the EMF is 20.4. And the total current there, it was 1.2. And the R external is 16.5 plus the R. Then if you do the math there, it divide by 1.5, divide by 1.5, this and this cancel, and then your R, it will be 0.5 ohms, right? I hope that makes sense, guys. It's a very interesting question, a very nice question. Cheers, bye.